Introduction to Nuclear Chemistry. What is nuclear chemistry? It is the study of reactions that are caused by a change in the nucleus of an atom. And when this change occurs, it becomes, and I'm going to replace the word another with the word different. So when this change occurs in the nucleus, it becomes a different atom. Nuclear chemistry does not have anything to do with electrons. The whole focus is on the protons and neutrons. So nuclear chemistry, the nucleus of the atom. So it's based on the contents of the nucleus, which are the protons and neutrons. The stability of a nuclei is specifically based on the ratio of protons to neutrons. The most stable ratio for any nucleus is if the ratio is a 1-to-1 of protons to neutrons. So over on this side, we have a little graph that scientists have developed. The green line on the graph represents the ratio of protons to neutrons, a perfect 1-to-1 ratio. The red line that curves represents the stable nuclei where the ratio is close enough to 1-to-1. So here the ratio is close to 1-to-1. So these nuclei whose protons to neutron ratio falls on the red line are considered stable. Large atoms, heavy atoms, they are elements with an atomic number greater than 83, are naturally radioactive due to an unstable nucleus. There are too many neutrons in the nucleus. Okay. Smaller atoms, the nucleus is relatively small. And smaller atoms, they tend to not be or not naturally radioactive. But of course, there are exceptions to this. When an atom's mass is greater than its typical mass as shown on the PT. So the mass of the atom on the PT. So when that mass becomes too great, then it becomes unstable. Great example of this would be the carbon isotopes. Carbon-12, okay, which makes up the largest abundance of all carbon atoms, has 6 protons to 6 neutrons, so it has that perfect 1-to-1 ratio. It is a completely stable isotope. Carbon-13 makes up 1.1% of the total isotopes. It lacks that perfect ratio of protons to neutrons, but the 6-to-7 ratio, it's close enough. So the ratio here happens to be close enough, so it is considered stable. However, you remember from your earth science days that when the carbon-14 isotope is formed, okay, it makes up less than 0.1% of the carbon isotopes. The proton ratio of 6 protons to 8 neutrons, it's too far off of that belt of stability. So the ratio is not a stable ratio. So this is an unstable isotope. It is radioactive. And you guys should remember from earth science days that the carbon-14 isotope is used for radioactive carbon dating. So this is used to date fossils.